Welcome to the second term evaluation 2017 Maths, grade 6, part 1. We are asked to answer all the questions on the paper itself, and each question gets 2 marks. Question number 1, part A. Blank is the common point for the two circles. Right. So when we look at the two circles, there are 5 letters: A, B, C, D, and E. Right. Here, D, E, and B are clearly not lying on both circles. D is lying only on this circle, B is lying on this circle, E is not lying on either of the two circles, and C is lying here on the border of the second circle. So if we had to pick one, we go with point A because it's lying on both this small circle and the large circle here. So I write the letter A. Part B, blank is the point outside the circles. So outside means not belonging to either of the two circles. If you look at letters A, B, C, and D, all 4 of them have some connection to the circles, but E is clearly outside both of these circles, so the letter that comes here is E. Moving on to second question. Question number 2. An educational trip starts at 6:25 a.m. It finishes at 5:10 p.m. Find the time taken for the educational trip in hours and minutes. Right. So we are starting off at 6:25 a.m. Now from 6:25 a.m. to 7:25 a.m. That's 1 hour. Like that, we can keep going. 7:25 to 8:25 a.m. 8:25 to 9:25 a.m. 9:25 to 10:25 a.m. 10:25 to 11:25 a.m. 11:25 to 12:25 a.m. 12:25 to 1:25 p.m. Keep going until we get somewhere close to 5:10. 1:25 to 2:25 p.m. 2:25 to 3:25 p.m. 3:25 to 4:25 p.m. and 4:25 to 5:25 p.m. So we have gone from 6:25 a.m. to 5:25 p.m. by increasing 1 hour at each point. Now, how many hours is it? 6:25 to 7:25, 1 hour. 7:25 to 8:25, another 1 hour, then 2 hours. 8:25 to 9:25, 3 hours. 9:25 to 10:25, 4 hours. 10:25 to 11:25, 5 hours. 11:25 to 12:25, 6 hours. 12:25 to 1:25, 7 hours. 1:25 to 2:25, 8 hours. 2:25 to 3:25, 9 hours. 3:25 to 4:25, 10 hours. At 4:25 to 5:25 p.m., 11 hours. So altogether, it takes 11 hours to get from 6:25 a.m. to 5:25 p.m. But in our question, they are asking us to get from 6:25 a.m. to 5:10 p.m. not 5:25. We have to get to 5:10. That means we have gone a couple of minutes extra. How many minutes is that? From 5:25 to 5:10, what's the difference? 25 minus 10, that is 15. So we have gone 15 minutes longer than necessary. So from the 11 hours, we have to subtract 15 minutes. From the 11 hours, we subtract 15 minutes. Right. So to do this, what I'm going to do is I'm going to break the 11 hours into 10 hours and 1 hour. 1 hour. This 11 hours is made up of 10 hours and another 1 hour. So I leave the 10 hours as it is, and from this 1 hour I subtract 15 minutes. So if I subtract 15 minutes from 1 hour, what happens? This part becomes, from 1 hour if you take away 15 minutes, 1 hour is 60 minutes. From 60 minutes if I take away 15 minutes, I end up with 45 minutes. So this part gives me 45 minutes. Here the 10 hours are separate. Altogether 10 hours plus this 10 hours, this 10 hours plus this 45 minutes will give us the total time, which is 10 hours and 45 minutes. Right. So that's the most basic way of doing it. There's a different way of getting the answer, a bit shorter. What we can do is we start with 6:25 a.m. and then we can write that in the 24-hour clock, which is 6:25, and our finishing time is 5:10 p.m. Now if we convert this to the 24-hour clock, we know that the minutes doesn't change. The 5 p.m. means you have to add 12 to this hour, the number in the hours part. So that is 12 plus 5 is 17. So we have to go from 6:25 to 17:10. Right. So instead of going from 6:25 to 17:10, I will start by going from 6:25 to 17:25. So from 17:25, if I deduct 6:25, 17 minus the 25 is cancelled, and I get 17 minus 6, which is 11. So 11 hours. But we are supposed to go to 17:10, not 17:25. So we have gone 15 minutes extra. That 15 minutes I can deduct from 11 hours. And as before, when we deduct 15 minutes from the 11 hours, we get 10 hours and 45 minutes. So both ways you will get the same answer. Moving on to question number 3. Right. So question number 3. State the following equipments which are used to verify the planes. So this one is what constructors use when they want to check that the horizontal surface is at the required level. So we can call this one the horizontal surface. This, on the other hand, is used to make sure that the vertical surface is at the correct level. So we can call this one, from up to down rather than sideways. So we can call this one the vertical surface. This is similar to this one, only this is used for checking that the horizontal surface across a longer distance is at the correct level. So again, this is horizontal surface. Right. Question number 4. Write the names of three quadrilaterals in the space given below. Right. So the important word here is quadrilaterals. Quadrilaterals are shapes that have 4 sides. So for example, a square, or what they have given here, which is a rectangle. Right. So since we came up with square, we can write square here. And once you think a bit more about 4-sided shapes, we can come up with 2 others like trapezium and parallelogram. So remember, the important word is quadrilaterals, which means 4-sided. Question number 5. They have given us 2 vessels, vessel A and vessel B. According to the drawing, vessel A contains 400 milliliters of water and vessel B contains 100 milliliters of water. Find the volume of the water to be poured from vessel A to vessel B so that vessel A and B have equal volumes. Right. So if I pour 50 milliliters from vessel A to vessel B, 50 milliliters, what happens? Vessel A will have 400 minus 50, 350 milliliters. Vessel B will have 100 plus 50, 150 milliliters. Right. If I pour another 50 milliliters from vessel A to vessel B, vessel A will have 350 minus 50, 300 milliliters. Vessel B will have 150 plus 50, 200 milliliters. So I pour another 50 milliliters from vessel A to vessel B, 300 minus 50, 250 milliliters, and 200 plus 50, 250 milliliters. So now we get 250 in both. So to get 250 in both, I have to transfer 50 plus 50 plus 50 milliliters 53 times, that is 150 milliliters. If not, what we can do is take the 400 milliliters in vessel A, take the 100 milliliters in vessel B, add the 2, we get 500 milliliters. Now divide this by 2 equally, so we get 250 milliliters. Each one should have 250 milliliters if they are going to be equal. So to go from 400 milliliters in the beginning to finish with 250 milliliters, from 400 deduct 250, we get 150 milliliters. That is how much we should pour from A to B so that they both have the same amount. Question number 6. Write this number in words as a standard form. Right. So here, units, tens, hundreds, thousands, 10,000, 100,000, million, 10 million. So how many millions are there? 12 million. 500,000. and finally there's hundreds, tens there underneath 4. That's the answer. 12,500,000 4. Question number 7. If it's true, mark a tick, or if it's false, mark a cross in front of the statement given in the table. 0 is a positive integer. Well, that's wrong. 0 is not positive, it's not negative either. So it's not a positive integer. That statement is wrong. Next one. The numbers represented on the number line are integers. Yeah, integers. -1 is an integer. 1, 2 are integers. Integers are whole numbers, so that's correct. Next one. 4 is greater than -4 is false. Is 4 a larger number than -4? Any positive number is larger than a negative number. So this is true. But they said it's false, so that's wrong. Next one. 8. Circle the wrong step in the following workouts. A. 3/4 plus 1/8. So this is the sum. This is the original sum, so there's nothing wrong with that. Next one. What they have done is they have tried to get the same denominator here, 4 and 8. So LCM of 4 and 8 is 8, so they're leaving this one here as it is. Here they're trying to convert this 4 into 8 by multiplying by 2. If that's the case, they have to multiply this 3 also by 2, not by 3. So the wrong step is here actually. To be more specific, the wrong step is here. 3 times 3. It should be 3 times 2 or 2 times 3. Right. Next one. 7/10 minus 1/5. Again, this is not wrong because it's a question. Once more, we are trying to get the same denominator. So we are multiplying 5 by 2. So top also times 2. That's also okay. 7/10 minus here 2/10. Because 2 times 1 is 2. 5 times 2 is 10. That's correct. 7 minus 2 is not 9. That should be 5. That's the wrong step there. Question number 9. So blank 0.54 is a decimal number less than 1. Write the suitable digit in the box to the box. So if it's less than 1, it should be 0. Tenth one. Underline the suitable methods to change a cuboid into a cube. Right. So if you compare a cuboid and a cube, cuboid looks something like this, where all the sides are equal. Now cuboid will be a bit different, maybe something like this. So the suitable methods to change a cuboid into a cube. In a cuboid, all sides are not equal in length, but in a cube, all sides are equal in length. So if we equal the length of the sides, that's correct. Reduce the number of vertices. Vertices are these corners. So if you count and check, in a cuboid and a cube, the number of corners are the same. The vertices are the same. So changing it won't do anything. That's not a correct step. Reduce the number of faces. If you count the number of faces are here, these surfaces, you will find that the number of faces on a cuboid and a cube are the same. So reducing the number of faces won't change a cuboid into a cube. So that's also wrong. So the only correct one is part A. Question number 11. There are 1,600 students in a school. An average student in a class is 32. Find the number of classes in the school. So right, here they're saying there are 1,600 students in a school and in each class there are on average 32 students. Now we are asked to find the number of classes in the school. So what we can do is we can divide this 1600 total number of students by 32 to see roughly how many classes there are. So let's divide. How many 32s in 1? 0. 32s in 16? 0. 32s in 160. In 160, if you multiply and check it, there are 5 32s. So 5 times 32 is 160. 0, bring this 0 down. In 0 there are no 32s. 0. So 50 is the answer. 1600 divided by 32 equals 50. 50 classes. Pick square number. Question number 12. Pick square numbers less than 20 in the given figure. So square numbers, we can write them. 1 times 1 is 1. 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. 4 times 4 equals 16. And 5 times 5 equals 25. So square numbers less than 20. So 6 times 6 will be more than this. So we can't go to 25, cut that off. These are the square numbers less than 20. 1, 4, 9 and 16. Now let's see if how many are there. According to our calculations, 3 is not a square number. 10? No. 12? No. 4? Yes, 4 is. 16? Yes, 16 is. 20 isn't. So the answers are 4 and 16. Right. Question number 13. Draw the next pattern. So here we start with one ball, then they have added 2 balls below that, and the next one we take this second shape and add 3 balls below that, and the fourth shape we take the third shape and add 4 below that. So basically what we are doing is we are drawing the shape, the previous shape. If you look, the previous shape is here, and we are adding couple of balls more. And how many more? So if it's the third shape, we have to add 3 to the bottom. If it's the fourth shape, we have to add 4 to the bottom. Like that. Take the previous shape and continue. So since this is 1, 2, 3, 4, 5, fifth shape, we add 5 to the bottom. 1, 2, 3, 4, 5. And the layer on top of that should have, this entire shape should come here. That's it. There is 1, 2, 3, 4 here. 1, 2, 3, 4. Then 3. 1, 2, 3. Then 2, 2 and 1. So you can check that. First shape only 1. Second shape 2 at the bottom. Then 1 less. Third shape 3, 2, 1. Fourth shape 4, 3, 2, 1. So fifth shape will be 5, 4, 3, 2, 1. That's it. To measure the radius of a cardboard circle, how many minimum folds you have to fold it? So to measure the radius of a cardboard circle, so imagine you have a cardboard circle like this, and you want to get the radius. Radius means from the center to the circumference. So in minimum, what you need to do is you have to fold it once. Because once you fold it once, you get, if I fold it from here like this, you get a shape like this. Right? And you can measure this one and divide that by 2 to get the radius. So the minimum number of folds is 1. Question number 5. Name the types of the angles given below. A. So they have marked it like this. This means it's a 90-degree angle or a right angle. And here This one, now if you draw a straight line like this from here to here, this is 180 degrees. But this is more than that, it's going a bit more than 180. So anything more than 180 and less than 360, we call that a reflex angle. (16) Write the suitable numbers in the space given below. Right, so we are starting with 18 and told that 18 is 1 times 18. Another way to get 18 is 2 times which number? 2 times 9 will give us 18. So we are starting with 1, 2, let's try 3 here first. Which number times 3 will give 18? That's 6, because 3 times 6 is 18. Right. Next question, question number 17. Find the perimeter of the triangle. To get the perimeter, you have to add the lengths, add the 3 lengths. So this length plus this length plus this length, that is 12 cm plus 8 cm plus 10 cm. That's the perimeter. Perimeter is the total length of all 3 sides. So 2 plus 8, 10, 10 plus 0, 0, 1, 2, 3, 30 centimeters is the answer. Question number 18. Write the decimal number represented in the abacus. Now in the ones place there are no beads. So 0, point, first decimal place, 10th place there are 2 of them. 2, and 100th place there aren't any, so 0, 0.20 or 0.2 is fine. Question number 19. If a number is rounded off to the nearest 10, the answer is 40. Find the minimum value it can be taken. Right. So if I round off 39 to the nearest 10, it becomes 40. 38 also becomes 40. 37 becomes 40. 36 becomes 40. 35 becomes 40. But if I round off 34 to the nearest 10, it becomes 30. So the minimum value it can be is 35. Question number 20. Find the total number of squares in the figure. Right. So let's count. This is 1, 2, 3. 3 squares. Then we have this larger one, 4. This one, 5. This one, 6. This one, 7. And finally the overall large one, that is 8.